Hello, cherished viewers. Welcome to Teach Connect, connecting minds, expanding knowledge. Don't forget to subscribe, share, and comment for us to get your views with regards to our content that we'll be uploading. I'm Perthra, your facilitator today, and today's presentation is focused on integrated science. Today, we'll be looking at some three key aspects in relation to energy. So we'll be treating the strand energy and we'll look at some three key substrands under this energy. So what are our learning outcomes? Let's quickly go straight to our learning outcomes. So by the end of this presentation, we'll be able to define the word energy as well as the respective unit to use. 2. We'll be able to know the types of energy that we have. Then 3. We'll be able to also know some forms of energy that we have. I hope you enjoy your presentation. Let's go straight to the point. Now, when we hear the word energy, what comes into our mind? One may reflect from the primary, JHS, SHS, and even up to the tertiary. The word energy simply means the ability to do work or the capacity to do work. And the unit of measurement for this energy is joules. Now, the unit written against it is capital J, but in writing the word, it starts with the small j, as we all know. Very, very key. So now we know that energy is the capacity or the ability to do work. So even in my presentation today, what has helped me to stand here is the energy that I'm having in me to be able to do this presentation. With respect to the camera also is using an energy that is helping the camera to record this video. So energy is very, very vital in our environment or in our daily lives. Now, let's go to the next issue of concern. We are going to look at the types of energy that we have. We have two types of energy. The first one is renewable source of energy, and the second one is non-renewable source of energy. So, we'll dive deep into the renewable source of energy. As the word goes, renewable, anything that can be replenished, that can be replaced. So we can explain that renewable sources of energy are infinite sources of energy that can be replenished after use. So we can go deep by saying that they are sources of energy that do not get finished or can be replaced after use. They are abundant in supply. Now let's take note of this. One primary source of energy in the ecosystem, in the universe, in our environment is the solar energy. Without the solar energy, the whole universe grinds to a halt. Living things are going to suffer, which we are part of. So the solar energy is one primary source of energy that we have. We can also talk about the light energy as an example of renewable source of energy. Light energy. We can also talk about heat energy. All these things are examples of renewable sources of energy around us. So the light energy, the heat energy, the sun energy, and many more. Let's go to the non-renewable sources of energy. So we can say that it is the extreme opposite of the renewable source of energy that we have. So the non-renewable source of energy are sources of energy that are finite in supply and cannot be replenished after use. Finite in supply and cannot be replenished after use. That is, they exist in limited quantity. They are not abundant. We can also say they are scarce in supply. That is in relation to demand. So let's look at some examples of non-renewable sources of energy. So we have crude oil. We also have natural gas. We also have petroleum products derived from the crude oil. Then we can also talk about uranium, also an example of non-renewable sources of energy. So when you go to Cape 3 Point in Ghana, the Jubilee Field, that is where we extract our crude oil. Time immemorial, that is from the beginning, Gold Coast, now Ghana. We didn't even visualize or thought of the fact that one day we will have crude oil. But currently speaking, we have crude oil. Looking at the quantity, the time that we discovered crude oil in Ghana, we can say that the quantity is gradually decreasing. So this should tell us that it will get to a time that it will get finished and can't be replenished or can't be replaced. When you talk about petroleum gas, yes, recently there was a shortage in the supply of gas to Ghana to power thermal plants to generate hydroelectricity. So this all gives evidence that these sources of energy, examples of sources of energy that we are talking about specifically, non-renewable sources of energy, exist in limited supply. Now, let's look at some key facts about the uranium aspect that we are talking about. Uranium is not a fossil fuel, but can be converted into a fuel to be used in nuclear power plants. Very important mineral. Now, with that said, let's move to some forms of energy that we have. So, in today's presentation, we are going to look at only 3, but in our subsequent presentations to come, we'll look at other forms also, and we'll look at these 3 that we are going to talk about into details. That is, we'll dive deeper into them. So the 3 forms of energy that we are going to consider under this presentation is 1. Potential energy, 2. Mechanical energy, 3. Kinetic energy. So let's start with mechanical energy. So mechanical form of energy is a sum of potential and kinetic energy. So to make this easily understood, let's go back and take our definition for potential and kinetic energy for us to be able to understand mechanical energy. So let's start with potential energy. This is the energy possessed by a body at rest, a car parked, a dog at sleep, a pencil lying down, a book lying down. So it is an energy possessed by a body by virtue of what? Its position. So when I stand straight and I don't move my hand, I don't do anything, the body is at rest. Therefore, my potential energy can be calculated. When I start moving part of my body, like jogging, running, my potential energy cannot be calculated and therefore goes into another form of energy. So potential energy, from our explanation, is the energy possessed by a body by virtue of its position. Now let's look at the formula in calculating potential energy. So in order to calculate the potential energy of a given body at rest, 1. We must get the mass of that body in kilogram. 2. The acceleration due to gravity, we must also get it. Then the height, we must also get it in meters. So when you multiply all these 3 things, your mass times your gravity times your height, you get what? Your potential energy. And because it's a form of energy, the unit is also very, very key. That is joules. That is J, capital J. Now with that said, let's move to the kinetic energy. The kinetic energy is also an extreme opposite form of the potential energy. What do I mean by that? So kinetic energy is the energy possessed by a moving body, a body in motion. This time around, not a body at rest, but a body in motion. Yes, so if I'm running, you can get my kinetic energy. If I'm jumping, if an object is falling from the top to the down, you can get the kinetic energy. You can calculate the kinetic energy of that object. If a car is moving, if an aeroplane is moving in the skies, if a train is moving, if someone is swimming in a pool, you can get the kinetic energy of that person. So these are instances or examples of kinetic energy that we can have. When you are sweeping, when you are cooking, when you are washing, all these are bodies in motion, and therefore we can calculate the kinetic energy of these various bodies. Now let's look at the formula for calculating kinetic energy. So the formula goes like this: half mv squared. You have your half, you have your mass also, then you have your velocity squared. And in simple terms, what we can derive from this velocity is the speed of that moving object. So to be able to calculate potential or kinetic energy, the formula goes half mv squared. Your half is there, your mass in kilogram, then your velocity is also there, and your final result will be in the unit of energy, which is also what? Joules. Now, understanding potential energy and kinetic energy, let's go straight to the mechanical energy. So we are saying that mechanical energy is a sum of the potential and the kinetic energy. What do we mean by sum? The addition of the potential energy and the kinetic energy will give us the mechanical energy. So the formula is E1 is equals to PE plus KE, and it also has the unit joules. So we have been able to look at the definition of energy and a unit. We have been able to also look at the two types of energy. We have been able to also look at three forms of energy, despite we have many. Before I continue, don't forget to subscribe, share, comment, so that we get your views with regards to our various content that will be uploading. Yes. In our next presentation, we'll look at these three forms of energy into details, how to calculate them, some tricks or tips to know when calculating these various forms of energy. Very, very key. I know you don't want to miss out. So, click on the notification bell so that immediately we upload this content, you'll be the first to get it. Follow us also on Telegram with the same name, Teach Connect. Thank you very much. Have a wonderful day.